The three questions. And it's three to answer to. The first one is moments. Moments. Moment of a force. That is, it has to do with turning force of a meter. Like, you want to find out the center of gravity of that meter when you put a certain weight. Center of gravity, what does that mean? That means the point where you will keep that object so that it will not what? To balance. Abi? Yeah. If it doesn't balance, means it's what? Rotating or it's tilting. That's why they say moment of a force. So that's the first question. So that one is a meter rules and then a knife edge. People have seen all these things.
Yes.
Then the second one is no. The second one has to do with Charles' law. Heat. When you heat up a metal or heat up a body, the expansion, the change in volume, the change in what? Temperature. That's the second experiment, but I'm not sure we're going to perform that one. I'm not going to perform that one. Mr. Promise will not perform that one. And the second one is electrical. Electricity. That one we're looking for the resistivity of a body. Remember resistivity, the ability of a body to what? Resist current. Yes. Or the measure of resistance of a body or a conductor. So that one involves what? We're going to use a resistor, we're going to use a potentiometer, we're going to use battery, we're going to use ammeter. Right? Yes. So now the main thing now, the issue is not even the practical, the issue is the plotting of the graph and you're getting your table of values. Now, there is a question that has to do with first question that have to do with that. Okay, now this one now, it's not exactly the question, but it's similar. It's an electrical problem. So now they performed the experiment and they got the what? Reading. Do you understand? Yes. You perform the experiment and you guys will get your you have a table of value. Now that table of value, they will ask you to plot a graph. You don't know what they will ask you to plot. Do you understand? All we know is that from the table they will ask you what to plot. They will tell you which one will be on the x-axis and which one will be on the y-axis. They might tell you resistance should be on the y-axis and distance should be on the x-axis. So based on what they do, you now use those values and plot your graph. Use those values and plot your graph. You have a plain sheet. Okay, now let's assume now this particular experiment has to do with resistance and what? Current. Do you understand? Yes. It has to do with resistance and current. That means at certain resistance, certain current was what? Measured. What was used to measure the current? An ammeter. Are you supposed to see the ammeter? Yes. You're supposed to be in one lab. Yes, ma'am. Let's go. Yes, ma'am. The lab is dark. That's my point. Let's go to the lab. It's used to measure current. There are different types of ammeter. This ammeter is a 2-amp ammeter. That means look at the calibration. It stops at 2, right? This one is a 3-amp ammeter. Because if you look at the calibration, you will see 5 and what? 3. So when it's connected, it's used to measure the current. It's used to measure the current. This is the switch. This is the what? The switch. The key. Please don't touch it. This is the key. When this thing is not here, it means that there is no current going around. once I put it here, it means that it's on. It's a switch, right? This is the battery. We are using 2 batteries. One of the battery is 1.5 volts. So if we have 2, that would be how many? 3 volts. Then we're using a 1 ohm. We're using a 1 ohm watt. Resistor. We're using a 1 ohm watt resistor. This is a jockey. This is a jockey. Okay? Now this jockey is what we're going to use to connect this potentiometer of different distances. Do you understand? Now this is to be connected. This is a potentiometer. Potentiometer is like a conductor, but they arrange it on a what? On a ruler, on a meter rule, so that you can measure the distances. So this jockey, when you put this jockey now, it's connected to the circuit. You put it at this, maybe they will ask you to put it at 30 centimeters. You look for 30 centimeters, right? Then you touch one of the wires, then you check your reading, right? Then you record it. They said, okay, do 30, 40, 50, 60. For 40, you put it there and you check your reading. For 60, put it there. 50, put it there. You check your reading, you record it. Right? Now when you do all those recordings, first of all, they will tell you to set up the circuit. Eh? They will give you a diagram of how you set up the circuit. The circuit might be series or parallel. You see the diagram, how they connected everything. You replicate it here. Then you start performing your experiment. Then when you get your table of values, you now go to your sheet and then you now start plotting your graphs. So now let's go to the graph section. Now, I'm assuming it's not the question, but this particular question is related to what? Electricity. This particular experiment is related to electricity. That is why I am using it. Question 3, 1991. Okay. Let me read it out. In a circuit diagram shown below, R is a resistance box, X is an unknown resistance, E is a battery, P is a key, K is a key, and A1 and A2 are ammeters. The top of the resistance box is also shown below, where shaded circles are indicated. So this is the diagram that we gave them. Are you seeing it? This particular experiment has to do with different resistances. The way you connect with resistor boxes in parallel or series. This question has to do with that. The plugs are inserted and on shaded circles indicated that plugs have been removed. With the circuit connected up and the key closed, the resistance box is set at a known value. But in this case, we will check the value of the ammeter reading when the jockey is not connected to anything. We'll record it. That's our first recording. So now, let's assume we already have the table of value given already here. At 3 resistance, 3 ohms, we got what? 4 amp and 2 amp. There are 2 ammeters for this question. These are the readings they got. And the question asks them to subtract. You follow the instruction of your question and use it to set up your table. Do you understand? You don't know the question. They might tell you to do anything. They might tell you find the reciprocal. They might tell you multiply this by this. Anything they ask you to do, put it on your table and give us the result. Do you understand? Yes. So when you do that, you will now wait for the instructions. They will tell you what to plot. What versus what will you plot. Do you understand? So you say, read and record the values of arrow. That's how you know what to do on your table. Do you understand? Based on what they ask. Arrow, the values of I1 and the values of I2. calculate Z. Z is what? I2 into bracket I1 minus I2. That means your table will have I1, will have arrow, right? We'll have I1, we'll have I2, we'll have I1 minus I2. Then we'll have I1 into bracket I1 minus I2. That's why you do your table. All the things they say you should find will be at the top of your table. Then you get the different values. You get the different values. Then now they say tabulate your reading. Now plot arrow 1, arrow inverse against Z. See? They can choose anything and tell you to plot. Do you understand? They can choose anything and ask you to plot. So this was they said they should plot arrow inverse against Z. Arrow inverse against what? Z. So let me see. Now this is the table. Let's draw the table. Let me show you how to draw the table. See here, it's good to use your rough sheet first to draw the. First of all, use your rough sheet to draw your table because there will be plenty mistake. I get you. Plenty mistake will be there. So you have to do what? Use a rough sheet. Do you understand? I'm using this as an example. This is not a question, it's just similar. Just similar. Even Sam was there. Sam would have helped us to replicate it exactly how it will be for tomorrow. But we went somewhere. So this exam was really simple. This particular only 5 digits. Who has cleaned? Now we have serial number. That means 1, 2, 3, 4, 5 readings each. Now the first is the resistance in what? Ohms. Resistance in ohms. Put it down. You what? You put it down. Now the second reading was current for the first ammeter in amp. The third one is the second ammeter, which is I2 in amps. The third one is what? I1 minus I2. The fourth one is Z, which is the question. It says Z is what? I2 into bracket I1 minus I2. You follow the question. See how I'm forming the table based on what they asked you to do in the question. Then they also said we should do arrow inverse. Arrow what? Inverse. Right? So now, these are the readings we got when we did our experiments. The first resistor, we set it at 3. This is the resistor boxes. We set it at 3. The second resistor was at 6. The third resistor was at what? 9. The fourth resistor was at 15. And the fifth resistor was at 30. Now, when we put that resistor, we now measured our ammeter, right? We saw a reading happening on this ammeter. We took that reading and we wrote it down here. We also checked the reading of the second ammeter and recorded it down here, giving us what? This one was what? 4. This one was 2. This was 3. This was 1. This was 2.7. This was 0.7. That's they have already performed it here. This is 2.4. This is 0.4. This is 2.2. This is 0.2. Now, this one was what we performed. This is what we performed. Every other thing here you calculate. Do you understand? Every other thing here will be calculated. Same in your examination. The one that you will get from your experiment is here. That's the one that we will help you. You will perform it. We will also help you to perform it. We will give you this one. Everybody will have this one. But you will go to your seat and calculate these things. This other one. Do you understand? Now, how do you calculate I1 minus I2? You can tell me. Simple. 4 minus 2 gave you what? 2. This one now is 3 minus 1 gave us what? 2. 2.7 minus 0.7 gave us 2. 2.4 minus 0.4 gave us 2. 2.2 minus 0.2 gave us 2. So how do we calculate Z? I2 brackets I1. We already have brackets I1 minus I2 here. So we are multiplying this by this. 2 times 2. 4. This times this. 2. This times this. 2. This times this. Use your calculator. 0.7 times 2. That's okay. Times. You see, those are the little mistakes. You have to be very careful.
0.7.
In fact, this exam is very simple. The one that will give you them plenty decimal places. Some of them have 4 decimal. 1.4. Just that electrical experiments have lesser decimals. 0.4 times 2. 0.8. 0.2 times 2. 0.4. Right? Yes. So are we clear how they derive this? Yes. We are clear. So how do we derive R raised to power minus 1? Who can tell me? R raised to power minus 1. From here?
Yes.
So how do we get this? For this first one, how do we get this? That would be 3 raised to power minus 1, which is the same thing as 1 over 3. Abi? To use a calculator is 0.33. Isn't it? Now, what's the inverse of 6? 6 0.167. You have to write it. You have to write it to 3 or 4 decimal places. Eh? Now, what is the inverse of this? 9. Inverse of 9. 1 over 9.
0.11.
0.1. Okay. What is the inverse of 0.1? Are you seeing how it was derived? This is not the question, but for you to have an idea that your table you are going to derive, there is a part that you perform in the experiment, and there is a part you will what? Derive. 0.067.
No,
excuse me. Okay, so it's 3 decimals, so it's 667. Then this one, inverse of that. 0.0333. Okay, so now we've got now they said plot what? Plot what? Plot R inverse against what? Z against Z, right? So what do we have here? Okay, R inverse, that means it's Y axis. This will be on the Y axis, right? And this will be on the X axis. Anytime they tell you plot V against T, just know that the first one is the Y axis and the second one is the X axis. So now we'll now draw a. You have your graph sheet, right? Yes. It's a graph sheet. Now this is your graph sheet. Eh? Now they say this part is very important. Plot what? Arrow inverse. That means these values against what? This value. Now this value is ranging from what? 0.3 to 0.3. This other value is ranging from what? 4 to 0.4. Right? So now on the Z axis, what scale are we going to use? What scale are we going to use? First, what did I say? I said if the values have minus, it will be a T graph. But if the values don't have minus, it will be an L graph. So this kind of graph now, we're not going to do it like this. I'll do it as an L graph. Because I want to make use of this space. So I chose for the Y-axis, That is arrow inverse 1. I chose what? Sorry. For the x-axis, I chose 2 centimeters to represent what? 1. Okay, so that would be, this is 0. Give me biro. I prefer biro. This is 0, right? Don't use biro.
0.1.
Don't use biro. When you are done, you can use biro. This is 1. This is 2. I said 2 centimeters to represent 1 unit. This is 3, and this is 4. Now, this x-axis is what? Is what? Z. We will indicate it. It is Z. Now, this is the tricky one because we have so many decimals. Abi? Now, this started from 0.0. Why this ended at 0.3? That means we need about 10 boxes. We need about 10 boxes. So we have how many here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? Let me use pencil. First of all, I will say, okay, now x-axis is 2 centimeters represent 1 unit. Y-axis will be what? 1 centimeter represents 0.1. Yeah, 0.1 what? 0.1 unit. Where's the cleaner? See there. Yeah. I will say 1 centimeter represents 0.1 units. So now, is that working out? 1, 2, 3. That will not work out. So let's say 2 centimeters represent. So we say 0. So we say 0.1. Are you seeing it? The second 2, 0.2, right? The third one, 0.3. The next one, 0.4. Then we put what? Arrow raised to power -1. So I've covered the range. The highest was 0.33,
Yes.
The lowest was 0.033. So now we'll start plotting. See now my graph has covered those values. This is 0.3. This is 0. So my graph will be this side. Your graph should be large. The least your graph can be is 210. If it's less than 210, you are failed. I know you cannot fail.
Amen.
So now, the first reading is what? 4 and what? 4 and 0.33, right? Let's write out our points. The first point is what? Which one is on the x-axis? 4, abi? So we say 4 and what? 0.333. Second point is what? 2 and what? 0.167. The third point is what? 1.4 and 0.1. The fourth point is what? 0.8 and 0.067. The fifth point is what? 0.4 and what? 0.033. So we are plotting all these points. This first point is 4 and 0.3. So we say 4. We're looking for 4. This is 4, right? No. Then 0.0 what? 0.333. 0.333. Huh? 4. Yes. Now we will count. Do you understand? For you to have accuracy, we will count. You know that there are 10 here, Abi? Yeah. There are 10 in this box. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So these two boxes will be what? 20. Right? So let's divide that 20 into 10. That's 4 for each, right? 20. Okay, so 10 is two boxes. So now we need 0.33, Abi? So 0.3, where will 0.33 be? So we'll count 0.31, 0.32, 0.33, 0.34. Now I'll give us 0.3333. right? So it will be somewhere here in between 0.33 and 0.35. So it will be here. So we put an imaginary line, and stop at 4. This is 4, right? Imaginary line. Where did that line? This pencil is not clear. So let's. Okay. So now this is P1, right? Biro, please.
Biro.
P1 is what? 4 and what? 0.333. Right? So we've gotten P1. Now P2 is what? 2 and 0.167. So we'll look for 2. This is 2, right? And 0.1 what? 67. This is 0.1 and this is 0.2. So we have to look for where is 0.167. Now we will divide this into it's 20. We know it's 20. So we are counting two steps, right? So 0.11, Abi? 0.12, 0.13, 0.14, 0.15, 0.16, 0.17. So it's in between 6 and 7. So it will be above the center. Somewhere here, right? Above the center. This is somewhere to 2. This is 2. This is 2. This is 2. So this is what? P what? 2. 2 and 1.6. 1.1? 0.117. Or 0.17. You save yourself first. So this is decimal. The next one is 1.4 and what? 0.1. 1.4. This is 1, this is 2. 1.4 is in between 1 and 2. The center is 1.5 already. So now let's look for 1.4. So we count 2 boxes. This is 1.4. 0.1. This is 0.11, right? This is 0.1, 0.11, 12, 13, 14, 15, 16, 17, 18, 19, 2. We are looking for 11, Abi? So it's the second, you count 2. The second 2 up there. The second 2. You see the stress? Under exam condition now, you'll be battling all these things. It's something you have to do by yourself. You can't help it. Nobody can help you at this point. So P3 is what? 1.4 and 0.11. Is that what? Yeah, if you write it like that, it shows that you know what you are doing. But even if you don't write it, it's not bad. You understand? Okay, so the next one is what? 0.8 and what? 0.6. Let's say 0.07. Let's round it up. 0.8. So where is 0.8 here? On this line. Beautiful. It's between 0 and 1. So we divide it into 10 and choose 8. Abi? So now it's 2, 2. We know it's 2, 2 because we chose a scale of 2 centimeters. So we say 0.1, 0.2, 0.3, 0.4, this is 5, 0.5, right? 0.6, 0.7, 0.8, 0.8, 0.8. And what? 0.07. So 0.07 here, where will it be? It's between 0 and 0.1. Abi?
Yes.
So that's, we'll count 7. So 1, 2, 3, 4, 5, 6, 7. This is 7, right? This was what? Was it here we chose?
Yeah.
Yes. Okay. So we'll use our ruler and we'll connect it together. So this is P4. I'm writing it so that people will know, but you must not write it. 0.07. right? P5, 0.4, 0.03, 0.5 and 4 and 0.03. 0.4 is before 0.5. Right?
Yes,
So
yes.
this is it. Then 3, we'll count. 1, 2, 3.
Maria passes.
You pass it.
This here.
You pass it.
Okay. So say 1, 2, 3. So P5 is what? 0.4 and 0.03. See? And mind you, tomorrow there will be plenty decimals. This electrical is even has the less decimal. The other one has so many decimals and so many zeros. So you have to be very careful while doing it. Okay? So now we have gotten our points, right? So we are going to join our points. We are lucky that it's almost a straight line. It's almost a straight line. So we'll do this. That's it. That's our graph. Now in this graph, they must ask you to find the slope.
Yes.
That one is compulsory. They must ask you to do what? Find slope. What is slope? Slope is the change in what? The one I'm seeing here, okay. The change in the y-axis all over the change in the x-axis.
I didn't
So the slope, right, is what? Equal to the change in the y-axis all over the change in the x-axis. Now we know our y-axis is what? R. Our x-axis is what?
Z.
On the graph, our y-axis is this part. Our x-axis is this part, right? Change, equal change, means the distance, we will now draw like a tangent. It's already a tangent, right? So what I usually do, I'll just choose 2 points on this graph. 2 equal points on this graph. Okay, no. Yes. So we can choose this part. You can choose this. You can choose this. Any point on the line.
I'm videoing
And this. I can see it. I chose this point and this point for my slope. Eh? Now this point now, give me this point now, slope, right? You said change in y all over change in x. Change in y means, now where is y? For this point, what is y for this point? 0.3. 0.3. What is the change in x? What is the corresponding x for this point? I think it's this point, eh? Between 3 and 4, right? So say 3.1, 3.2, 3.5, 3.6. That's 3.6 minus the second point now is what? 0.15. 0.15 is at the center. Choose a point that is easy for you to locate. Now the corresponding x will be what? Now 1 point what? This is 1.9. Abi? 1.9. So subtract 0.3 minus 0.15 is equal to 0.15. Then subtract 3.6 minus 1.1.
1.7.
1.7. So calculate it with 0.0 what? 88. So that's it. That's it. It's not easy. But it's not hard. It's not easy, but it's not hard.
Yeah. This Z. This Z.
Which has been drilled at the 50 centimeter mark. Suspend the object marked at 10 centimeter mark of the meter rule. It's almost the same thing. On the other side of the pivot, suspend the known mass and adjust its position until the rule balances what? Horizontal. Read and record the distances of D and D1 of mass and M1 respectively. There are two masses. But in our case, we might use only one mass. Read and record the distances. So. Repeat the experiment. In fact, this particular experiment is very long. I don't know why Sir said we should do it. It should be very long. For each mass, we're going to record at about 5 different distances. And we have like 5 masses. So we're going to have like 5 tables. We're going to have like what? 5 tables. For each table, we're going to reduce the distance. Okay? So I don't know what they did here. So now, when we are done with that, we will plot a graph. Do you understand? We will plot a graph. Now they ask us to do what? Tabulate your values D1, D2, and D1 minus D2. That means your table now you have what? Serial number, right? You have mass. You have what? D1 and what? D2. Then you have D1 minus what? D2. Put it on the table accordingly. But what is fixed is the mass and the what? Distance. That's what you got from the experiment. You get them from the experiment.
Hope you understand.
You will calculate the other ones. Like D1 minus D2. You will calculate it. Abi? If they say inverse, you calculate it, Abi. If they say square something, you calculate it, Abi.
Yes, ma.
So that's what it is. So that's what we have here. We now said plot what? Plot a graph for D on the vertical axis and D1 minus D2 on the horizontal
in class.
Simple. Is it simple? So when you have your table, D1, right? And D1 minus D2. Okay, give me graph sheets.
Graph sheet, give ma.
You people are going to do go to your class now and do it. This is 1, 2, 3, 4, 5. When we did the experiment, we got 10, we got 15, we got 20. This is even fixed. This is not even the experiment. This one is given. We're trying to measure, put the mass at different lengths, right? Now, this is what was deduced from the experiment. D1 in centimeter, which is what? 20, 17.5, 15.20, 12.50, 10.30. D2 centimeter, 17.20, 15.04, 13.10, 10.74, 8.88. Now, D1 minus D2 centimeter. Your assignment now, as we are looking, get this value, and then plot vertical axis. Plot plot what? Plot D1 minus D2 and D1. You understand? Then find the slope. Slope. You know that the slope is changing y and changing x.
Thank you, Thank you so much for the. If you have questions, ask. Go.
Go and do the assignment. I can use chalk and write and draw it on the board.
Thank you, man.